about the Bobby drop table. And by the way, don't try this at school. I mean, that's not nice. And the other thing you could do is actually use a SQL command, which is union or union all, which gets two tables and puts them together. So you could get some other table that is more interest for you, and then try to concatenate those and use the S keyword in order to set up the name of the fields you want to show correctly. And if you don't know how many fields you need or what their types are, you can always use type null, which goes back to any type in the system. So again, as we saw with cross-site scripting, we saw some flawed defenses. Here I want to call out some of the defenses that I see over and over, and they just don't work. So don't fall for them. The first one is people looking, okay, somebody is actually entering this single quote all the time, and the single quote is pretty bad. So I'm going to actually remove the single quote from the input. Well, basically, if you're doing that, you don't have a security problem, you have a usability problem. People like Mr. O'Reilly or O'Donnell or O'Brien, they're going to be very mad at you because they no longer can use the system correctly. So don't do that. On the other hand, some people think, okay, I can also escape the quote if I cannot remove. And the way you escape in SQL is basically doubling up the quote. And here's some code. It's very typical for somebody who just found out that in order to escape the quote, you have to double up the quote. The person just put a replacement here, and then whenever you have a single quote, you just double up. And look what happens in this code. Basically, before you used to have the username, which was varchar 25, and the old password, new password, which is 2525. If you do the quick math, you end up with 75 characters here, and the command is 100 characters. Now let's suppose for a minute that suddenly I put the old password, and it's all quotes. Basically, instead of 25 characters, I'm going to end up with 50 characters. If I do that for the username and the old password, I have over 100 characters already. And look, the size of the command is 100 characters. What happens whenever you have a SQL statement that is bigger than the size of the variable? In C++, a lot of people would say buffer overflow. Well, that's not the case in SQL. What happens is actually truncation. So one thing an attacker can do here is something like that. If the person passes 18 single quotes, one capital letter, two lowercase when one digit, and as the new password, and the username as administrator, what's going to happen is that SQL is going to truncate the rest of the statement, which happens in the second line right after the plus, if you do the math. Basically, what's going to happen with this statement is the old password is going to be truncated and no longer part of the query. In other words, you can replace the old password for the administrator with a new one without knowing the old password. Very interesting attack. Another thing that you see people doing over and over that is wrong is actually to use the store procedures instead of having the SQL statements in their code. They just hear store procedures is a good way to avoid SQL injections. And that's not the right story here. Basically, if you do a store procedure as the one you're seeing on the screen, you're actually concatenating data, which is always bad from a SQL perspective. The right way of doing things is actually the way we see in the screen right now. And here's an example with C#. It's using parameterized queries. And here's the parameter, the @name that you see in the first line. And then this parameter is added to the query whenever needed. If you like this topic about seeing how vulnerabilities really work, giving a try, understanding more about them, I definitely encourage you to do this kind of things, because the more you understand, the harder it's going to be for an attacker to use them against you. A very good tool for that is called WebGoat. WebGoat is made by OWASP.org. It's a free tool. And this tool is a web server that was made vulnerable on purpose. Here's the lesson that on SQL injection. If you don't get it right, it will give you tips on how to get the things right. And you keep trying until you get, for example, the lesson accomplished. So we talk a little bit about SQL injection. We talk about cross-site scripting attacks. And I want to spend the rest of this lecture talking about encoding. I think encoding is just insane in all the types of encoding you have today. Einstein once said, insanity is doing the same thing over and over again and expecting different results. My question to Einstein would be, what about the opposite? What about doing things different in many different ways and then having the same result for those things? Wouldn't that also be insane? In other words, if you have to do all this filtering, if you have to look at all this input that could be completely different sometimes and make sure this input is valid, that would be completely mad. What you see on the screen here is a web page, and in the first line in the body, you see, is this insanity? And then you see the same thing over and over, but represented using the decimal notation, hexadecimal, Unicode hexadecimal, some JavaScript, and notice the way you represent the characters in Unicode is slightly different from HTML. And you see again in hexadecimal, octal, you see is in functions. In the last one, you actually see doing some math. It's doing actually a bitwise AND between some number and 127. So it's really hard for somebody to actually parse all those things and realize they all mean the same thing. Why I'm showing this to you? Because when you do input validation, if you don't do it at the right time, you might end up having to analyze all this kind of inputs, all these goofballs that somebody can actually throw at you and make sure they're okay. So whenever I talk about encoding, I think about JSON, because it always comes back to haunt you, right? If you consider, for example, the less than character in URLs, there's a bunch of ways they can be represented. You can do the %3 C, or you can represent %25 3C. %25 is actually the percent, and it's just double encoded, and that would work, and the URL would be resolved. So likewise, for Unicode, there's several ways you can represent a character. For example, the question mark, there's 2 ways you can represent the same thing. And if you are going from multi-byte to Unicode, there's some ways that you can do the conversion and some flags that you can use, such as the best fit. And what best fit does is actually whenever a character is not present in a certain code page, it will use whatever is more how can I say, similar to that character. So for example, for the infinity character, it would translate to 8 because it thinks it's, kind of similar. For the prime symbol, it would actually translate to quote, the single quote, which could be a problem for SQL injection. So you got to be really careful when you're working with all this encoding. So just to demonstrate this problem that we had with Unicode characters and encoding, IIS 5.0 had a really interesting problem. Basically, it didn't know how to translate the %C0, %AF Unicode for the /. And what happened is somebody was able to actually break out of the sandbox where all your web pages are and go until the system32 directory where the command.exe is and execute it. If you can execute command.exe running as IIS or system, you can do pretty much whatever you want with the box, right? You could go and create the user Joe and add user Joe to the administrator group, some of the things that you can do. So when you thought that all this encoding madness